In this video, we're going to look at distance and midpoint. And a couple things before we start is just redefining things in the coordinate plane to make sure we're on the same page. And so this is the coordinate plane. The origin is where origin's like the beginning, right? This is where everything begins. It's at 0, 0. You start here. That's your reference point for everything. The x-axis goes left and right. The y-axis goes up and down, and that's the order of points, x and then y. Quadrant 1 is where everything's positive. So positive is over here to the right and up. So if everything's positive, that's where we start, essentially, right? So quadrant 1, and then angles go counterclockwise. So we're going to label quadrant 1 here, quadrant 2 over here, quadrant 3 down here, and then quadrant 4. And the last thing we'll mention is where things are positive and negative. So in quadrant 1, we have positive x values and positive y values. In quadrant 2, the x values are always negative and the y values are always positive. And then see if you can determine 3 and 4. This is a relatively intuitive pattern, but it's one that's worth pointing out and one that's worth trying to understand and realize that the quadrant you are in tells you a lot about the point. So if you're in quadrant 3, then you know the x must be negative because we went left, and y must be negative. And then quadrant 4, the x is positive and the y is negative. And the reason we talk about the coordinate plane is because often with the distance and midpoint formula, problems are centered around the coordinate plane. So if you need a little review on, plotting points or the coordinate plane, there it is. Okay, the distance formula. I personally do not like the distance formula because what I find is people can't memorize it for very long. If you work to memorize it in this class, you probably will. But then when you if you take the ACT in like a year, or you're preparing for the ACT in like a year, then you probably won't have it down. But what everyone remembers is the Pythagorean theorem. So we're going to say the distance formula is actually, we're going to do c squared is equal to a squared plus b squared. Okay, and let's draw a right triangle. Let's just draw one over here. Let's see if I can squeeze one in. So we'll put one here. It doesn't really matter where you put it. And we'll say these 2 points here. So if you wanted to find the distance between these 2 points, you would say, well, I could do A, B, and C with the legs and hypotenuse of this right triangle. And the distance is C. Okay, so let's just change this to D squared. Okay, and now I need a squared. Well, how am I going to find a? This is a little tricky. Actually, let's switch these. Let's make this b and this a, just to keep my x and y's in the same order. So a, here we could just count, right? You would just say, well, a is 1, 2, 3. But if I wasn't able to count, I would look at my x values because I'm going left or right, and I would just subtract. I would just do, well, what's this x value minus this x value? And find the distance. Okay, so that's x2 minus x1. That gives you the length of one side. And then we're going to square it because it's a squared. And then in a similar way, if I wanted to find this distance, I would just subtract. And it's y values. So it's whatever y2 minus y1 is. Or you could count if you plotted points. And then it's squared. And then we want to find distance, so let's get d by itself by square rooting both sides. Let me grab a different color. And there is the distance formula. So the distance between 2 points, x1, y1, and x2, y2, is subtract the points and square them. Subtract the points and oops, that's 1, and square them. Add them together and take the square root, or it's a squared plus b squared equals c squared. Okay, so that's distance, and we'll use it here in a minute. So midpoint. Midpoint is very tough to memorize, and in some cases it's even tough to use. But think about what else you know about the middle. Midpoint's just the middle, and a way to measure the middle or find the middle is to find the average. So find the average. And this is another thing that I see is people do not memorize the midpoint formula very well, or they don't remember it for very long. So once again, kind of taking it back to like an ACT situation, you might not remember how to find the midpoint, but almost everyone at this level of math anyway, knows how to find an average, or is very close to knowing, right? You add up the numbers and divide by the number of data points. So if we're going to find the average between the X and Y coordinates, then we're going to add up the X's, divide by 2. Add up the y's, divide by 2. So for the midpoint, we have the x coordinate, which is just x1 plus x2 divided by 2, and then the y coordinate, which is y1 plus y2 divided by 2. This is very difficult to memorize, I think, for two reasons. One, because we always kind of lump these together in math, and so you subtract up here, but you add down here. So that's confusing if you're just like memorizing it without understanding why. The other reason is you have a slope formula that you've learned before, and we'll probably go over that at some point in this class, but you have a slope formula, which is y2 minus y1. So it's very similar over x2 minus x1. So it's very similar to this, but it's different. So you get them confused. And so that's why I really encourage you to think about finding the average with this midpoint. Also think of the X and Y's separately. So think of it as like the X's do their own thing and then the Y's do their own thing. They're independent of each other. Okay, let's apply this to a couple problems. So if you need to, if you haven't written those down, write them down because they're gonna go away, or pause the video and get them written down. Okay, so this says two things: find the midpoint and the length of the segment with these endpoints. Now, I always recommend, if a problem gives you points, to plot them. It's a good way to check your work. It's also a good test-taking strategy. So we're down here at -3 and -4. And then -6, 1. 4, 5, 6, and then 1. So we have this length we're looking for in midpoint. And so it's not like you're going to be able to see it just by looking at it directly, but you will be able to check your work with it. Let's do midpoint first because it's said first. So that's just an average. So look at the x's, and we'll just do x. We'll actually label it capital M with a little x. So the x coordinate of the midpoint is add up the x's and divide by 2. And so that's -9 over 2, which is -9/2, or -4.5. And then we'll do the midpoint for the y coordinates. So treat them separately. -4 plus 1 over 2, which is -3/2, or -1.5. So here's the great thing about plotting points is if you mess up, your answer probably doesn't make sense on the coordinate plane. So let's see if ours makes sense. So 1, 2, 3, 4.5, and down 1.5. So it's about right there. And so that's the midpoint, and it looks like the midpoint. If you like sketch your own coordinate plane, it might not be perfect, but you should be close, right? If you mess up a sign, it might be over here or over here. So it's a good way to check your work. So the midpoint is, let's go ahead and write it together. -9/2, -3/2. And so the distance formula. Now, if it were me and I were doing this problem and I had these points plotted, I would say, well, let's just draw this right triangle and count 1, 2, 3, 1, 2, 3, 4, 5, and then use the Pythagorean theorem. Here we'll work out the distance formula because that's kind of what we're looking at. So we have subtract the x's and square it, and then subtract the y's and square it. Go ahead and pause the video and work this out if you haven't already. So when you subtract the x's, order doesn't really matter here because you're going to square it, so it's going to be positive. But we'll start over here. -6 minus 3. squared plus, and then y 1 minus -4. Let's see. So this is the square root. Here we get -3 squared. And then this is 5 squared. And so we'll write this in one step. 9 plus 25 is the square root of 34. Okay, and so you think, well, how can I check my work there? Well, the square root of 34, it's going to be close to 6. It's almost the square root of 36. So it's 5 point something. I'm just going to write ... because I'm not going to type in 5.8 or so maybe. And so you look at this and just kind of look and see if it makes sense. It's a little bigger than 5, and that makes sense because we know that was 5. So 5.8 makes sense. If you got something that was really small, like smaller than 3, that would not make sense. Or if you got a really large number, you can say maybe I made a mistake. So there's distance in the midpoint. Okay, pause and try number 2, where you are looking for the endpoint. Okay, let's label some stuff here. 1, 2, 3, 4, 5, 1. So this is the midpoint. We'll label that M, and then A is at 2, 5. So A is here. So right away, we would expect B to be down here somewhere. And one strategy is just to count, right? You can count using your graph. You can go down and over and down and over. Or you can line up the midpoint and endpoint. So let's do 2, 5, and then 5, 1, and then just figure out the pattern. So here we went -3, or sorry, +3 to get from 2 to 5. So add another 3, and you land on 8. Here you subtracted 4, so subtract another 4, and you land on -3. And you can see that looks pretty right, right in here. Actually, I'd have to count those out. 5, 6, 7. Yeah. That looks like it could be B. If you want to do it algebraically, think about average again. So our midpoint, we know 5 for the x's. 5 is equal to the average of the x's. So 5 is equal to x1, which we'll say is 2, plus x2 over 2. And then let's go ahead and write out the y. The midpoint's 1, and that's equal to the average of the y's. So 5 plus y2 over 2. And then solve each of those separately. So we can solve those by, I'm going to move this up. So we can solve those by multiplying and then subtracting. Multiply by 2 and subtract. So we got the same midpoint, 8, -3. Or sorry, not the same midpoint. That's for point B. Okay, this one's kind of tricky because it asks for the length of AB as well, or this question's kind of tricky. So always make sure you read well. And so let's just use the distance formula. You have your right triangle you could draw. As the points get further away, the right triangle becomes more tedious to count, although that one's not bad. But let's just find the distance. One thing, make sure you use the right points. So we're going to use 2, 5, and 8, -3. So subtract the x's, 8 minus 2 squared, and then subtract the y's, -3 minus 5 squared. And so here you get 6 squared plus -8 squared, which is 36 plus 64, which is the square root of 100, which is 10. And so this is an 8. Let's see, 1, 2, 3, 4, 5, 6. Yep. 8, 6, 10. It's a Pythagorean triple triangle. Okay, good luck with distance and midpoint, and reach out if you have questions.